the ones I saw the most were 3, 4, and 5, so we'll do those 3. 3 and 4 can be done in desmos, and 5 we should be able to look at. So for 3, if I type in those points, and I count that slope, well, let me backtrack. I know I'm gonna be writing the equation of a line, so I need my y equals mx plus b. And I can add my sliders. In order to change my m, I need to know what this slope is. So if I count it, I'm going down 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So down 6 to the right 12 would be a negative 1/2. And then I could move my b until it goes through both points. So then my equation would be y equals negative 1/2 x plus 2. Remember to put use desmos if that's what you did. If we are not using desmos, you should be, as your SOL is fast approaching. For number 4, you can put that into desmos as long as you change the variables to x's. So if I put that in, it's going to give me a line. And that line is at negative 17. So x equals or n equals negative 17 is that answer. So anytime you see anything to do with slope, equations, writing the equation of a line, writing the equation of a line that's parallel or perpendicular, you should be using desmos. Right, and then number 5. Christopher incorrectly solved the inequality as shown. So here they subtracted 1, which is a fine step. It's not what we usually do, but that's okay. Subtracted 1, so that's right. Distributed the negative 4, so that should be negative 4 plus 28. That's good. And then here they moved 28 over by subtracting. That's good. And then they divided, but they didn't change this sign. So the steps were between 4 and 5. If you were to put in this original into desmos, it would show you this, but the other way, shaded the other way. So that would also show you which 2 steps. Questions on any of those? We can factor any of these if you want to, but really these are here to remind us what the different types of factoring look like before we get into what we're actually going to talk about. Kind of mixed around. So if we have 3 terms, that's your trinomials. A equals 1, where you're looking for 2 numbers that multiply to be negative 15, but add to be 2. Or A does not equal 1. where obviously the number in front of x squared is not one, where you would multiply a times c, figure out what that is, and look for two numbers that add to be -7. And so those are your trinomials. If you have two terms, that's either GCF or difference of squares. If it doesn't have a GCF, do difference of squares, where you have two sets of factors, and you're looking for what times what will give you the first, and what times what will give you the last, and put plus and minus in between them. Yes. And then if you have a GCF, look for what they have in common, divide that out of everything. So in this case, what do these have in common?
What could we divide out of both of those? 5. What else? How many x's? X squared and, sorry, I didn't mean to do that. 5x squared and y squared. Let me make this pass really fast.
What can be divided
From everything.
including the
Yeah, so number wise, what can be divided from both, and then variable wise, the lowest exponent that everything shares.
If we divided that out with left, and then the inside is prime, and then there's nothing else left to do.
5 was supposed to be something with grouping.
But I'm not gonna make up something because it may or may not. But if you have four terms, pretend that had a fourth term, you split that down the middle. I'll just write that. Where you split the middle and factor out GCFs on both sides. So we'll need to keep all of those in mind as we go on to dividing. But first, we're gonna do some dividing polynomials by monomials. So ignore this for a second, we'll come back to that. Go to this page. So this is kind of going back to our polynomial operations, just the dividing piece of it. So some of our exponent rules come back into play. There are two ways to do these. You can either factor out the GCF and deal with that, or you can separate. I'm going to show you both for a couple, and then I'll leave yours choose. So if I separated that first, we take each term and put it over whatever the denominator is. That would simplify to be what? Plus 3, yes. And that would be your final answer. If you did the GCF, you're only doing that of the numerator. What do those have in common? 4. If I divided that out of both, what's left? But we have to still say that we're dividing there because the denominator 4 didn't disappear. And when you divide by the GCF, or when you take out the GCF, those should be the same. So then you could cross those out, and that would leave you with just 2t plus 3. So you get the same thing either way. It's really your preference, which one you would prefer. For most of these, they can all be done either way. There are some I'm going to show you separating might be better. If we were doing number two, again, we'll do both in this case. Let's GCF first. What would that GCF be? 1 and 1, 2, 1 e. If I factor out a t, what's left?
2t minus
And then if I cross out my like terms, what's left?
2t minus.
For the separating, I'm just gonna show that really quickly. If we were to separate it, 2t squared over t gives us 2t. Negative 9t over t gives us 2t times. Questions so far on this? Yes. When you factor out the GCF, you are essentially doing this, dividing out what's left. So you did t squared divided by t, and t was left. Okay, let's do one more. Let's skip to number 5. Do we want to do that by GCF or separating? Separating, okay. Eight a squared b divided by ab. 8a, 3b. Just like that. Questions on that? Okay, we'll do some more of those when we get back from lunch. We'll do 6 and then 8 and then the others you guys want to see me go over. The 4, 6, do we want to separate or use GCF? If you want to use GCF while we're doing separate, that's fine. If you were to separate them, put each one over 2t. And divide. And what would we get? 2t, you said that really fast. Squared plus. Questions on that one? Okay. 8 separate or GCF? Okay. So if we separate that one. Put each one over 9a to the third b. And what would be left when we divide? Grace, did you put your phone? Alright, so I'm gonna show you an example where GCF might not be the best example, but it will still work. And then that you may want to separate instead.
So somewhere where you have space, write this down. So we're gonna do the GCF so you can see what happens and then see how you would have to solve it or simplify it. And then we'll separate so you can see how that would also. So let's find the GCF of our numerator. What would that be? What did you say?
3xy. If we divided that out of everything, what's left?
-3, 8 x to the power of 2.
All over your 3x squared y cubed. Usually when we factor out the GCF, whatever we factored out in the denominator are the same. If you were to factor out the GCF and you see that they're not the same, this would be a good place to, in general, stop, erase, start over and separate. Or if you like what we're about to do, continue with this. So we're gonna rewrite this as this over this, the GCF over the denominator. And I'm gonna put everything else in parentheses next to it. And then I'm just gonna simplify this piece. What would be there? What would be left? One of the x's, there would only be one x, but it wouldn't be in the numerator. And there would be y squared, but again, not in the numerator. One over xy squared. And then bring this parentheses down. So then from here, we can't leave this like this. We would need to distribute this fraction into everything. So if we do that, what would that give us? Actually, I'm just gonna write it as is first and then we'll simplify it. So we have xy to the fourth over xy squared minus 3 over xy squared plus 8x squared y over xy squared. Then from there, we can simplify each. What would this be? Minus. Would anything simplify here? No, I would say the same. And then for this one? Over 1. So then you get something like this, and that would be your final. Though there would be more steps if you did the GCF instead of separating in this one. Now we're gonna do it again, and we're gonna separate and see what happens.
Once you have that, we're gonna divide each piece. What would this give us? Y squared minus 3 over x y squared. Which is the same thing that we got before. So separating it will give you the answer faster. GCF works, but it just takes a little longer. Questions about that? Max, if you have a question, reach out to us. Right. So now that we talked about how to divide polynomials by monomials, now we're going to talk about how to divide by binomials. So go to the I think it was the first behind the first. And we are going to factor the numerator. Find out things like that. So you have to know what type of factoring you're going to be using. This one is a trinomial. This is either an a equals 1 or a doesn't equal 1. Which one is this? A equals 1. Just writing that off to the side so we remember. So we factor that by finding two numbers that multiply to be 6, that add to be 5. Two and 3. So that would be x plus 2, x plus 3. And when we put that, we were dividing by x plus 3, the original. And then cancel out your like factors. And whatever is left is your answer. Yes. The a is just the number in front of x squared. Other questions there? Okay, let's do another one of those. Number 2, what type of trinomial is this? A equals 1 again. So we're looking for two numbers that multiply to be 27, but add to be 12. We're doing 3 and 9. When you're doing this, the a equals 1, one of the numbers is most likely going to be what's in the denominator. So when we cancel out our like factors, what's left? X plus 3. I'm gonna skip 3, Max. There's an invisible 1 in front of x squared. Number 4, is that a equals 1 or a doesn't equal 1? So first look, does it have a GCF? No. So if it doesn't have a GCF, then go on to the next step. Multiply 5 and 6. And then find two numbers that multiply to be 30, that add to be 15. Would that multiply to be a positive 30? 15 and 2, one of them would have to be negative, and we're multiplying to get a positive. It's not going to be negative. It's going to be 10 and 3. 15 and 2 wouldn't work any way you did that. Because one would have to be negative, but you can't multiply a negative and a positive to get positive. But then you would rewrite that into your 4 terms. 6x squared plus 3x plus 10x plus 5. You may need more space. Because in each step, you need to still show that you're dividing. You can't just get rid of the denominator. Split that down the middle. Find the GCF of the first two, which would be what? 3 and X. Which would leave us with 2 X plus 1. What could we divide out of the last two? Positive 2, leaving us with, I'm sorry, not 2. 2 would be what's left, 5. That'll leave us with 2x plus 1. So here you start to see what's going to cancel out, but finish it. Write your final factors before you do that. I'm going to write this off to the side. So we have 3x plus 5 and 2x plus 1 all over 2x plus 1. And then when we cancel out our like factors, our answer is 3x plus 5. Questions there? Yes.
Why is this one we put the whole numerator to be.
Ask your question again.
In the other one, we multiply A and C and then we just put that down to Y. And then ignore the other terms, but why is it that this one we write?
So this one, we didn't do A times C, we only looked at C. So this is solved differently. The A equals 1, you have to solve that. Yes, possibly, if the GCF took out the 6, and then you're left with an A equals 1, then you could go back to this. But if it's a GCF and you still have a number here, you're still gonna do this process. That number is just gonna be on the outside. Other questions there? Do we want to do 5? I see some yeses, okay. So does that one have a GCF? No. Then multiply 4 and 5. We're looking for two numbers that multiply to be 20, but add to be negative 12. And one of them would be negative 2. Both of them would be negative. Rewrite that into your 4 terms. If you put 2 first, that's also fine. That probably would have been better actually, but it's okay. Once you have your 4 terms, split that down the middle. What will we divide out of those first two? 2x. What would be left? 2x minus 5. And then what could we divide out of the last two? Negative 1. Which would give us 2x minus 5. And then if I rewrite my final factors, we have 2x minus 1 and 2x minus 5 all over 2x minus 1. We cancel out the like factors, what's left? 2x minus 5. Make sure that you are canceling out the like factors. Questions there? We're gonna go through 2 more types. And then what it would look like on the SLL, how to do it in Desmos. So if we got something like 6, we have 4 terms. That's part of your 8 equals 1, the grouping, where we split it down the middle, and then find the GCF for both sides. So what would that GCF be for those first two? M squared. What would be left? And then what would the GCF be for the last two? And leaving or M minus one. And then if I rewrite the final factors, we have M squared plus N and 4M minus one. All over M squared plus N. Cancel out our like factors, what's that? Four minus one, 4M minus one. Okay, and then the last type. M squared minus 9, how could we factor that? Which type of factoring? Let's start there. Difference of squares, yes. And then how would we factor difference of squares?
Change. It's two sets of parentheses, one has M and three
You're looking for what two numbers multiplied to be M squared? You split that up. What two numbers multiply to be 9? You split that up, put a plus and a minus. And then if we cross out our like factors, our final answer is M minus 2. Do you have any questions on how dividing polynomials by binomials works? Yes. It doesn't. Also, the other ones, if you had put this factor first, it doesn't matter. I just have a habit of putting the like factor on the same time. No, because I did that opposite here. It doesn't matter. Okay, if you don't have an iPad, go grab one. All right, we're gonna do number 1 on this SOL practice page in Desmos. Go ahead and type in 16x squared plus 40x plus 24. On the SOL page, type that in, number 1. When you finish that in separate lines, start putting in the answer choices. Once you have them all in, if you were to see a question like this, what is a factor? You can always do this algebraically. You have to remember how to factor. But if it's multiple choice or maybe a choose all, you could do this. Put in the original. It's gonna make this shape. We're gonna be talking about this next class. And then of the different factors, so if you did it alphabetically, you could see which factor is the right one. Or you're looking for which line crosses that shape at the x-axis. And only one of them does that. And that will show you your answer. So that'll work for any of your factors. You could even try problems that aren't multiple choice, like let's say you solve it or you factor it and you get two factors at the end, put them in separately without parentheses or anything, see if they do this. If they don't, you know something's wrong there. Something else, I'm gonna go back to the number 7 we just did. I'm gonna put that in, but with x's, because you can only use x's in desmos. So when you put in any of your polynomial division, whether that's multiple choice or not, put the problem in, it's gonna give you a line. If it was multiple choice, you could match that line to whatever your answers were. If not, you could look at your y-intercept, count the slope, and I can see that this line would be y equals 1x minus 3. Or just x minus 3. It's gonna overlap. I could also just take out the y equals. And I know that would be my answer because it overlaps. So while you're practicing, SOL practice, JLabs, Delta Math, be using these tricks for the dividing and for the factoring. Questions on that? Yes. Number 3. On that same page, like SOL practice and SOL math. You would type that in, but with X's. I did, you're right. And because you're dividing, if you started with something that's a square, you're not gonna divide and still get something that's a square. So eliminate any square answers, C and D, those are out. And then you could either put these in and see if they overlap, or actually do the work. Oh, this one, I think, was something that needed to be fixed. It was supposed to be a negative. Because of the way this is flipped around, there would be a factored out -1. So really it's like this. It's really more like this. I mean, that. But the GCFs don't show up as factors. So that one you'd have to actually do a little bit of the work, factor out that -1 as the GCF, and then put that in. So you could, let's say you rearrange this, put it in standard form, that would be -2x squared plus x plus 3. Factor out the -1. So let me show you what I was talking about. If I rearranged it and I factor out a -1, so that this would be 2x squared minus x minus 3. and then you put this on top of 2x minus 3, it would work. It would get one of these answers. But if you see what just happened, if you put that in and your answers are like the opposite, there was probably a -1 that you had to factor out. Just in case you missed it, x plus 1, I believe, was the right one. Other questions there? So you have a bunch of different things you could be working on, the practice and this, the Delta math that's due tomorrow, JLabs, your SOL practice that's due on Monday. Your math gap practice, that is now just SOL practice. So if you want to just practice that individually, not in your group, come get that check. You could be working on any of those things. Use the time wisely, work together, do desmos, and let me know if you need my help. Oh, yeah.